Today we're going to look at how to do the pH of a strong acid solution. Please turn to Worksheet 6 in your packet, and this will be the notes section here for this unit. So it says to calculate the pH and the POH of a 5 times 10 to the minus third molar HClO4 solution. I'm going to work you through a series of steps, which is what we're going to use for all acid equilibrium problems. In this case, we really can skip from the problem down to step 7 and not do any of these steps. But I want to illustrate to you that A, you can use these steps to do any problem, and B, it'll help you to understand what's going on in each of the steps as we start to use them further on. List the major species in solution. Well, we always have water, but we also have this perchloric acid. Okay, and we don't need to list water because it will always be there, so we need to list the HClO4. Choose the species that can produce hydrogen and write balanced equations for them. So species, sometimes there's more than one. We only have one thing, and so in this case there's no decision to be made. It's going to produce H plus ClO4 minus. Using the values of the equilibrium constants for the reactions you have written, decide which equilibrium will dominate in producing H plus. Well, there's no decision to be made because I only have one thing, and so therefore it will dominate. But we need to look at the equilibrium constants. The Ka, which is what the equilibrium constant is for an acid, we'll have Ka and Kb in this unit, along with Kw, is equal to large. It's a big number. And by large, it's large because it's a strong acid. It's not obviously going to be put in our calculator, because how do you put large into your calculator? But it's going to tell us that this is something that completely dissociates, that breaks apart completely. And this is true for all 6 of your strong acids. Write the equilibrium expression for the dominant equilibrium. Well, Ka is equal to the concentration of the products over the concentration of the reactants. Then we need to list the initial concentrations of the species participating in the dominant equilibrium. Well, I only have one thing. It's at HClO4, and my initial concentration is 5 times 10 to the minus third molar HClO4. Step 6 says we've already determined it's a strong acid. It will completely dissociate. So we need to write the change needed to achieve equilibrium. So if we have HClO4 and it becomes H plus ClO4 minus, if I started with 5 times 10 to the minus 3 molar of this, 100% of it will break into H plus and Cl minus, which means that ultimately I'll have 0 of that left. Then it says calculate the pH using the strong acid concentration. If I know that my H plus is equal to 5 times 10 to the minus 3 molar, I know that my pH then is equal to the negative log of that, which is 2.30, and I know that my POH is equal to 14 minus 2.30, so 11.70. And that completes our first problem. Notice we didn't need any of that work in the middle to do this problem, but it's going to make it much easier when we go to do our next problem.